And off we go. Hello, good afternoon to our European audience. Good morning to those joining from other parts of the world. My name is Adam, and it is my pleasure to welcome you to this very special consular webinar. Before we get started, I'd like to make sure that everything is working properly. So could you please just let me know in the chat whether you can see me, whether you can hear me, and whether there's someone here. That will bring me some comfort knowing that I'm not just talking to my monitor. So I'm looking at the chat, and indeed, I can see first comment. Perfect, wonderful. Thank you for doing this. Now, why is this webinar so special for us? There are two main reasons for this. First of all, this is the first time that we are unveiling our product portfolio to a wider audience. And in just a moment, I will invite our guests to join us on the stage to share more about it. And the second thing is about the timing. I'm really excited that it's only 3 weeks till Christmas, but this is not the timeline I'm referring to. In January, we will be launching our very own first satellite, the Skyview-1, a huge milestone that we've been all eagerly anticipating. And today, we want to share this excitement with you, give you a glimpse of what's coming over the next year. And with that, let's take a quick look at today's agenda. I think we have the introduction covered. Next on, we will move on to a brief recap of our technology and the future plans. This will be followed by an introduction to our product portfolio, and then the part that you are all probably waiting for, which is some brief information on the data applications. We've also reserved some time at the end for your questions. You will notice that there are two different tabs in Livestorm, one for chat and one specifically for questions. So feel free to drop your questions in the questions tab at any time. Additionally, we would like to take this opportunity to learn more about you. So we prepared some simple questions, and throughout the webinar, we will display them on the screen. The first two should appear right now. I'll give you a moment to fill them out. And in the meantime, let me introduce you who else you'll be hearing from today. To share Consular's vision and product roadmap, we'll hear from Beate Temple. Beate has very extensive experience in product management within the agriculture sector, and she now leads our product team at Consular. For insights into the data application, we will welcome my colleague Elsie Ibrahim. Elsie is just a treasure trove of geospatial knowledge, and she holds a PhD in remote sensing. She's responsible for developing our land surface temperature data layers. Before I invite Beate and Elsie to the stage, let me just give you a very quick recap of what we exactly do at Constellar. And when we first started the company, we carefully analyzed the satellite imagery market to identify gaps, what existing space infrastructure wasn't enabling us to see. We quickly then realized that for some of Earth's most fundamental elements like water, energy, and carbon, we lacked a crucial data point, and that is the temperature. So this realization set us on a mission to develop the most advanced tool for measuring temperature on Earth with incredible accuracy. With several of esteemed organizations that you can see on the slides, we've taken a significant step toward achieving this goal over the last couple of years. And with this, I present you the Skyview-1, the first payload in our Hive constellation. Honestly, seeing these images for the first time was just an incredible moment for all of us, the entire team. It took an immense effort, dedication, and passion to transform what was initially just a very ambitious idea into a payload that right now probably sits in a cold warehouse somewhere, just awaiting launch in, well, a couple of weeks. So looking at the slide, let me briefly highlight Skyview's specification. First of all, we are looking at very high spatial resolution. For the thermal sensor, we are looking at 30 meters. That's the native resolution of the sensor across 4 long-wave infrared bands. Additionally, on the payload, there is a veneer sensor with a 10-meter resolution. The other aspect is data frequency. I often bring it up during conversation with customers. Based on feedback we received, our long-term goal is to provide data daily, even sub-daily, and that should happen within approximately 2 years. Looking at the third element, the high accuracy, something that we often bring as kind of our main competitive edge. By leveraging the patented calibration technology and very advanced cooling system, we were able to achieve exceptional radiometric accuracy. We can detect temperature differences as small as 2 degrees Celsius within a single scene. That's very crucial for some of the applications that we'll be discussing today. Finally, the imaging capacity with a swath width of approximately 350 square kilometers per pass, SkyBio1 will be able to cover up to 1 million square kilometers per day. So how did we get here and what's next? As you can see on this timeline, in 2022, we launched our very first sensor aboard the International Space Station. That way, we proved that our technology actually works, and I think some of you that are present here today even had the chance to work with that data and also provide us a very invaluable feedback, for which we're extremely grateful. Over the past few years, we've worked hard to refine our product portfolio based on this feedback, but also by engaging with different stakeholders who share our mission. A major milestone in that journey was being selected as one of Copernicus' contributing missions, meaning that starting next year, our data will be accessible to many European institutions. We are already collaborating on pilot projects with some of them. And finally, we are getting to 2025. In just a few weeks, SkyBio1 will be launched into orbit. Following this will be a commissioning period to ensure that everything functions correctly, and data should be delivered to first customers in mid-second quarter of 2025. SkyBio2, so the second satellite, is scheduled for launch in June 2025. And by the end of 2027, as you can see on the timeline, we aim to have at least 5 satellites in orbit. That would enable us to do daily monitoring of every location on Earth. This is just the beginning. Our long-term vision includes a constellation of up to 30 satellites. And with that, I think it's high time to bring our very first speaker today. Beate, are you with us?
I am with you.
Terrific.
Fantastic. Thank you very much, Adam. And likewise, also from my side, good afternoon, good morning, good evening, everyone, wherever you may be. And I just checked the guest list or the participant list, and it's great to have so many people from all around the world actually joining our webinar. So thanks a lot for making that time. Now, Adam has already introduced me in the beginning. My name is Beate Temple. I'm leading product in Constella, and it's really my biggest pleasure today to introduce you to our portfolio for 2025. And I don't want to make it too much of a reveal because, with some of you, we have already talked in advance about the data layers we will be offering in 2025. For some of you, it may be a completely new information. So therefore, I would really love to talk you through very casually into what we're offering in 2025. Now, before we actually get there, let us actually take one step back and look at just the general trends and why surface temperature or thermal information is actually important, and why is it such a critical variable for us to look at, and why we're building all our company around that particular variable. And when you look into the big trends in the world, temperature is essentially one of the most crucial biophysical parameters defining the water and the carbon cycles, and thus temperature really influences all living organisms, people, plants, animals, as well as the built infrastructure of our world in any place around the world. So that said, temperature is really a key variable, and we want to better understand it to really monitor climate change, the implications of climate change, and temperature can do its piece to serving as a crucial data point in order to inform and assess any type of climate adaptation and mitigation measures. Now, when you look into, just the implications we already see of climate change today, the consequences are already very visible, and can be felt. They are enormous already today and will further intensify in the next years to come. Now let's look at the big trends, particularly for the agricultural, urban, and infrastructural sectors that we already see today. So in agriculture, we see already today that droughts are heavily impacting large parts of the agricultural land, with significant implications on the yield. In 2023 alone, 60 million hectares of cropland were affected by droughts, and that stress had significant implications on the yield. And with every degree of global temperature increase, there is expectations that crop yields will further reduce significantly in the key crops. So it's about time to really understanding with temperature all of these trends best possibly to then drive smarter, more informed, and sustainable resource management decisions in the agriculture sector. And likewise, if you go into the urban environment, even today, people are already suffering big times from intensified heat stress. Roughly 70% of people live today in cities. And just in the last decades, the days with more than 35 degrees in cities have increased by over 50%. And we're expecting more of these very hot days to come. And that is causing today already significant fatalities. More than 300,000 people annually die from urban heat stress or stress induced by heat events. And the number is, dark-wise expected to be much higher than that. By 2030, just the city of New York City is expecting to be spending roughly $55 million US per year on implementation of heat mitigation measures. So just that, I think, gives us a dimension of how big the trend of, or the need really, of using thermal information in any dimension will be to drive best-in-class mitigation measures and to be effectively working with data in our hands to drive good decision-making, also in the urban environment. And last but not least, if you look into the infrastructural and the built environment overall, already today we have quite some heat-induced problems, and those will significantly worsen, driving up costs for maintenance of our transport infrastructure, in this case, significantly. So under a 4-degree global warming scenario, which we're all hoping we're not going to get to, we would see rudimentary increases in annual expenses for just maintenance of the road and railroad infrastructure of about 5 billion per year in the EU and UK alone. Now think of that on a global scale. That's incredibly intensive, and it's just making the need also in the built environment more and more obvious to have good data, to take well-informed decisions, to actually work with the resources we have, with the infrastructure we have in the best possible way, and enable sustainable resource decisions all around the globe. Now, this is where, we are coming in. And today there is a lot of kind of comprehensive information on air temperature already out there. It's quite granular and it's available for every place at any moment in time. Now, we at Constella want to drive that not only air temperature becomes accessible that easily and that universally, but also surface temperature becomes likewise readily available and accessible. Because today we're quite limited in using land surface temperature. We don't have high resolution data available, and therefore we also cannot yet use high resolution data points or readily available surface temperature information to enhance decision making for sustainable resource use. Now at Constella, we really, really want to change that. And we aim at generating the most comprehensive thermal insights over time to monitor any type of temperature-induced stress on the surface, and thus drive successful implementation of data-driven climate adaptation measures. Now, we want to make thermal intelligence as easily as possible available so that everyone can use these data points to benefit from continuous readings for various applications around the globe. Imagine a world where satellite-based thermal intelligence is available truly for every point on Earth at any moment in time, where you can just click on a map or on any point in the map and see detailed surface temperature readings for that location, with everything that you need to know about the surface. Now, that would be a world in which not only geospatial experts, and I know many of you are geospatial experts, but also other people and mainstream applications can actually start using geospatial thermal information at their fingertips. And so many mainstream applications can start benefiting as well from easy access to this information. So think of it, at one point in time, if we were to succeed with this vision, it would be possible to monitor the heat stress of plants in your garden. And you could use that information to drive, with your smart garden system, better irrigation decisions every day in your backyard. Now that, of course, is a fantastic world, or would be a fantastic world, and we hope that at one point in time we get there. Now, unfortunately, today, we're not yet there today. And as many of you know, especially everyone who has joined us from the geospatial expertise community, we have a lot of challenges that we're actually facing that we need to overcome in making geospatial data in general, but in particular as well, thermal information more mainstream, more easily accessible, more usable for the purposes we believe they can be used. Now, we want to take many of you, ideally all of you, along with us on this journey of getting to this long-term vision. But as we're not yet there, let's go back to reality today and to where we're standing and what is going to be our offer in 2025 for you. Now, in 2025, we're offering 3 distinct land surface temperature data layers. And you may ask, 3? That's quite confusing. Now, let me talk you step by step through those 3 data layers. They are designed to serve specific purposes so that each data layer can be embedded for specific needs of our customers into an application best possibly. Now, first and foremost, we're going to offer our signature data layer, LST Precision, which is our 30-meter native resolution dataset coming directly from Skype, as Adam had introduced in the beginning. Additionally, we will offer an LST Zoom product, which is, again, our proprietary dataset, but enriched and sharpened to a 10-meter spatial resolution so that you can use that information for zooming in on anomalies with best visually resolved land surface temperature. Now, both of our proprietary data layers will be available with very high frequency in a refined swath of about 15 kilometers for you by mid-2025. And when I say high frequency or with a high revisit rate, we are expecting with the first satellite to have a revisit rate of 4 days, going down to 2 days by mid-year, and then down to 2026 daily revisit, so that you can benefit for both data layers from continuous monitoring for your application. Now, last but not least, we are also, with all hands on deck, already developing our data fusion efforts for you so that you can already benefit in 2025 from LST Fusion, a data layer that is a fused data source of the various publicly available data sources and our own proprietary data layer, perspectively, to really allow you to use thermal readings for large areas with regional coverage, and I think that is a very important point here, with reliable data frequency. Because as many of you know, today, geospatial data is difficult to use because of various reasons. Accessibility is still a challenge, and availability in particular is often scattered or distracted by topics such as cloud cover. Now, we are working towards making thermal intelligence available as a continuous reading. And so LST Fusion will be available for you with a reliable data frequency, meaning we will provide you on a regular basis in the beginning, every 8 days, with a data set. Now, I'm sure there's a lot of questions you may have on the data portfolio, and I'd be happy to have more discussions with you in the Q&A section. From my side, I would just want to stress one topic, which is we are working on all different areas on providing high precision, high accurate, absolute temperature data, because we truly believe that with such an information, making that information available as a continuous reading, we can change better decision making all around the world in sectors that I had outlined and beyond. Now, for 2025 already, we are going to have an improvement over current public data sets of about 10x better resolution, 10x better performance, and thus are expecting to enabling for you a lot of new possibilities using thermal information and thermal intelligence. Now, that said, I'd be very curious to understand a little bit, and hope that still many of you are engaged with us, how you're using land surface temperature today, and where are you actually facing, in which dimension, limitations for the applications that you're interested in. I'll give you a moment to fill in the survey. And assuming that everyone has just participated, thank you very much for your information here. Now, I'd love to call Elsie to stage to guide you through what is possible and what has now become possible with high resolution land surface temperature data to actually leverage that information in different type of applications, to just give you a glimpse of where we're pushing the boundaries. And we, of course, love to hear more and more applications from your end in the Q&A. Thank you from my side, and over to you, Elsie.
Hello, thank you, Beate. Thank you, Adam, as well, for the great introduction. So happy to be here, and so happy also to see later the polls and what everybody present is doing. Thank you so much for taking the time to be with us. Well, what I would like to share with you first is what more or less I do at Constellar. So I'm actually part of the Insights team. And the Insights team tries to see how this land surface temperature currently available, plus the one that we will have, would contribute to solving problems that our customers need to solve. And how we can also solve new problems that now we discover we could actually do with these data sets. So that's what we try to do. And we try to do that in various environments that are important for everybody and that are key. And LST is also key for those environments. Now, Beate already introduced how LST is essential for many of those environments. And indeed, it is key. It is a surface condition that helps us to understand the Earth's surface energy balance and is essential actually for all of them. So I will not go into all of the details that already Beate covered. She gave a great introduction to that. But I will add to that a bit that the fact that we are working also with satellite data brings great opportunities. And as you see in this map, it's just an example of some of the things I will talk about and the locations of the use cases I will show you in a minute. And they are all over the world. And that's the power of working with satellite data, is that we get to see many places, we get to learn about a lot of places. Many places become accessible to us and therefore also to our customers. At the same time, LST data, as we said, is key, is a key surface condition, but also it's a very dynamic one. And that means it needs really monitoring, and we need as much data as possible. One snapshot every once in a while is not really enough. And so again, with our fleet of satellites, this is going to be really a great contribution to solving a lot of problems. And Many of these topics that I will just very slightly give examples of are actually our efforts at the Insights team and great teams we have at Constellar in collaborating with other companies in the private sector, with research institutions, but as well as internal studies that we do in order to understand certain use cases and the usefulness of the data for certain use cases. I will start with some examples from agriculture. Now, as we already heard about LST being very essential there, and of course it's a key driver for surface air energy exchanges. So therefore it is essential in order to understand and gain insights on the soil, on the vegetation health itself, on water availability, on climate dynamics. And here I will share with you three use cases that we have worked on and some illustrations of applications where LST can be useful. The first one that I'm going to talk about is on the left side, so the figure on the left side. And it took place in India in collaboration with RMSI Cropelytics. And so we'd like to have a shout out to them as well. And the idea there was that we wanted to see how LST data can contribute to understanding impacts on yield. Now, we already know LST data can be a great layer in yield prediction models. So we were not trying to predict yield through that. We were trying to see if LST can give an indication that there might be something wrong with the yield, but also early on. So it's two-dimensional, let's say. And so we worked with them on that. And the great aspect of this thermal data is that it actually was able to give continuous temperature coverage of large districts in India. And so that is great because we could cover so many areas, so many fields. It was really a study at field level. And then from there, indeed, we understood that LST greatly contribute to this kind of yield prediction. And in fact, it can give indication of issues that could be with the yield more than 40 days prior to the harvest. And so that means even starting at flowering and grain filling stages for the wheat crop that we were analyzing, we could actually know for which fields there could be an issue. And so this kind of early warning can be really an opener for great opportunities in order to, in a simple manner, understand the impacts on the yield. Now, the second case that you see in the middle, no, sorry, can you go back to the agriculture? The second example that I have in the middle is a case where actually we look at it from a very different perspective. So for the yield in India, we looked at so many regions and many AOIs, and here we looked at just one simple field. And this field had a great experiment because part of the field was not very well irrigated and the rest of it was well irrigated. And the experiment was to see, with some machine learning approaches, can we actually see with LST when there is an issue? Can we detect this non-irrigated part of the field early on before, for example, NDVI could detect it and so on? So we tried to do that. And we monitored the growing season of this field. It was maize. And throughout the growing season, we were able to find, of course, with the data that is not with a great revisit time, but it was more or less more than 10 days before we could detect it with NDVI, that we could detect it with the land surface temperature. And so both of these examples actually, we really look forward to revisiting them once our data is out there, because that means, as Beata said, we have tenfold better data, tenfold more frequent data, and hopefully all those results that we have now are going to be improved tremendously. The third story I wanted to share with you here is actually the ability of people to be able now to build on these great land surface temperature layers, modeled applications and applications that are more complex. For example, evapotranspiration modeling. And we also did that work as well. And we validated that work with flux tower networks. And here you have some examples. If you look at the DOI there, actually it's a reference that we shared, an abstract that we presented at EGU this year. I think it was this year probably. And there, if you click on it, you have an overview of what we tried to model and how we did the assessment and so on. But the idea from that is that you can also use these LST layers to model evapotranspiration, daily evapotranspiration. And from there, you can build various applications related to understanding also water stress, but also to go to more irrigation management and better improved monitoring of your fields. So our LST as well will make that even better. We can go then to some applications on the urban environment. Again, Beate introduced that very well already, so I'm not going to repeat why we need to do this. But of course, the idea is that with our geospatial data having also this big coverage, we can look at a city in an integrated way and understand different elements of the city. The rapid urbanization as well allows us to look a little bit in a fast way, in a quick way to follow how things are going. And understanding that helps us also to locate problems and suggest mitigations. Now, we know, unfortunately, that green spaces in cities are often very limited and around 15% of cities in general. And so we know that there is potentially a problem, but locating where it is exactly, how the resilience is in certain parts of the cities is very important. And at the same time, understanding if we set in a mitigation measure, if we green a certain area, if we use shadow material for certain areas, is it exactly improving things? How can we assess that? How can we monitor the trends in those regions? Is our investment really helping people? This is also really important and can be really also understood better with continuous land surface temperature. Now, not only is that we can look at the land surface temperature directly, as you see here on the left, it's at the city of Freiburg and it's different parts of the city. We can also compare land surface temperature or even use it for thermal comfort estimations. And so there are several indices. Here you can see a study, also shout out and grateful to the University of Freiburg for working on this. And so using our data there as well. We could see that there is a great link between land surface temperature and a thermal comfort index called the UTCI. Of course, there are also differences due to the difference in the data and also the scales of the data. And you can see here a difference between the UTCI values and land surface temperature. And what we noticed, for example, is that we have the highest differences when we are in the center. You can see in the photo an example of how those streets look like. With the resolution we have now, surely we cannot really check what there is at the street level. All the data is capturing is more the roofs. So that's why the data from land surface temperature, we expect it to still be higher than the UTCI that is modeled at the street level. And again, we really look forward when our data will be there, how much better this is going to be. But already it is really phenomenal that with comparing these two measures that we really have a good feeling and a good understanding of what's going on in the city. Now, the thermal comfort itself, it's about, the state of mind in humans. So it's about the satisfaction with the surrounding environments regarding the thermal conditions. But at the same time, this is really impacted by socioeconomics, and understanding also that and putting all of these layers within city features, we can understand also the thermal inequity that occurs in cities. And this is where you have the example to the right. And that is really key because many of the SDGs of the Sustainable Development Goals actually tackle aspects that are directly impacted by land surface temperature. So for example, the SDGs 3 and 7 on good health and well-being and affordable energy. So because you can imagine that your energy is impacted greatly with the increase of heat. These are really key SDGs that are very important that LST can play a role in contributing to those. And of course, SDGs related to sustainable cities and to climate actions. These are also very, very essential and key in understanding all these thermal inequities and these socioeconomic drivers for that. So again, we would love to see how this is all going to look like with our new data sets. The third applications I will also cover briefly is related to infrastructure monitoring. So Beate already explained as well the cost of all of this. So it's really key to understand how we can optimize maintenance, how we can have some kind of predictive maintenance as well. So understanding the vulnerability of the infrastructure and identifying very extreme exposures to cold, to frost, but at the same time also to very extensive heat that can allow us further on in time to be able to predict better and maintain better. And that's very important to identify these patterns. And these patterns also not only can be for the infrastructure, but also can be for power plants, for example, and industrial sites to understand patterns of activities and so on. Now, this is very important as well because many of those infrastructure elements use a lot of in situ sensors. So many of the people we have worked with on these applications have sensors all over roads and all over different areas that they are using already for their solutions. And what is their feedback with the greatness of the LST continuous data layers is that it's a great complement to those in situ sensors to really bridge in accurate information at very local scale to really great insights of integrated information at a larger scale. So I hope I gave you a general overview of some of the applications. I'm really happy to know more if you have any questions, and looking forward to knowing more about what you're interested in the Q&A. Thank you so much.
That was fantastic. Thank you, Elsie. Thank you, Beate. And we have everyone on stage. And just before jumping on to the webinar, I had a quick look to the list of participants, and I knew we could expect some very insightful questions, and you guys didn't disappoint. So let me read them one by one, and we'll ask you, Elsie and Beate, to answer them. So let's start with a question from Emmanuel. Is LST Zoom leveraging super resolution? If yes, is it Constellar algorithm or a third-party one?
And great question, Emmanuel. Thank you very much for that question. So in the first iteration, we are using data mining sharpening techniques using our 10-meter veneer bands. So that is what you can expect from the Zoom in 2025. Now, of course, here, we have built our DMS kind of modeling efforts on the basis of a publicly available model that we have adjusted for our own needs. And we do have, as you can imagine, with our large ambitions of making continuous data available and, resolving differently publicly available data sets to high resolution over time, we have a heavy investment in our roadmap into super resolution efforts. We're expecting to have improvements there over time, leveraging, also some AI-based super resolution approaches to just on the basis of only our tier bands to actually getting to, a 3 to 5x improvement in the resolution. I hope that answers your question.
I think so. With that, I think we can go to the second question, which is coming from John. So the question is, how will you make that available for specific AOI on a regular basis? GeoTIFF SYNs with no AOI minimums, or are you going to full scene with minimum requirements? And the second question from John is, will you allow access to the feed directly and engage with distributors and different implementation partners? That's how I understand it.
That's a lot of questions in one. So let me tackle them one by one. And Elsie, also please feel free to jump in here, so it's not only me talking. So part number one, how will we make the data available? I'm assuming you're asking for the data in 2025. So we're going to make the data available on an AOI basis with minimum requirements that are relating to at least the purchase of one scene. All data will be available in standard geospatial formats. So yes, absolutely, we're going to provide GeoTIFF formats that are accessible directly through our end user platform, where you can access all data delivered either through an API or directly through the interface. And will we engage with distributors or resellers? we are already in conversations with various distributors/resellers, and we cannot share a full list of where all our data will be listed in comprehensive kind of overview at this moment in time. But absolutely, you can expect that you will find our data also in some of the resellers.
So the third question is coming from Pauline. Are you processing the data on board? If so, which hardware are you using for that? And which tasks are being processed on board?
So most of the processing happens on ground. So we do have a fully in-house built processing pipeline. And we are essentially processing raw data from L0 to L2 completely in our own processing environment. So on hardware, we do have few processing capabilities only.
We have another question from John. John, as always, is coming with some very interesting observation on the state of the market and making the distinction between ERF monitoring and ERF observation. So the question is, will your product be at an affordable rate for serial different uses and deployment? So maybe I'll try to answer that question. We spent a very long time thinking about the business model we will offer to our customers, also by having direct conversations with them. And I think starting January, we will offer a very competitive model that, again, accommodates the use of many different groups. So whether that's a subscription-based pricing model, but also per capture model, we are ready to accommodate all your requirements and needs. Moving on to the question from Suzanne. So how can thermal intelligence, when integrated with geospatial technology, improve real-time decision-making in agriculture and urban planning? Any specific formats or methodologies that can be integrated? That's a tough one. We can spend a long moment talking about it, no?
Do you want to start answering that?
I can try. It's a tough one indeed. But maybe for me, I think we covered a lot what could be done on the geospatial aspect. But what really I think is challenging in the question is the real-time decision-making. That may be something we could talk about. So in 2025, we don't expect to have from our side real-time data, but it is really on our roadmap to reach that stage. So at the moment, we have some limitations in various aspects. We're happy to discuss that with you, but it's not things we can directly now control to get the real-time absolute temperature. But it is on our timeline to reach real-time data and even forecasts, because for agriculture also forecasts eventually will be very important. So that can bridge what is required for real-time, but it is not something for 2025 for us on our plate. I hope that answered the question. I don't know if Beate, you have a better answer, or Adam?
I think it's perfect. Maybe just as a kind of also recap or reflection a bit on the last two questions in combination, right? I think, I've shared it in my presentation part earlier with you. Our ambition as a company is really to making thermal data from, space more accessible, also more widely usable to a larger audience that goes beyond the geospatial experts that are today being able to use that data set. And I think, we are right now focusing a lot on all relevant data fusion efforts that we would need to get in place in order to being able to doing that. And our ambition of having a continuous data layer in place, would also significantly improve, of course, on the one hand side, the pricing, but also will significantly improve readily available data sets so that you do have reliable continuous readings at a given moment in time. And, I think that is perspectively where we're aiming at. Of course, as you nicely explained it right now, we're not yet there in 2025. So what you can expect from us is that we will more and more foster this transformative journey of making Earth observation thermal data readily accessible to everyone over the next couple of years. And we will, take all steps in that direction when it comes to latency topics, but also when it comes to data fusion topics, to making continuous readings available.
And if you'd like to go deeper on some of those topics, I'm just sharing in the notification, you can book a call directly with us if you'd like to discuss any kind of the topics we are talking about right now. Okay, two more questions to go. One from Philip. What is the 2025 target delivery time? How long after data capture can data be accessible? That's a good one. Beata, you want to take this one?
Happy to. I mean, we're aiming to have data available within maximum 72 hours. So you can expect that from capture to availability or usability of the data, there would be a maximum delay of 72 hours. Of course, we're trying our best to also be faster than that.
And the last question, more of a clarification, we're ready, really. So about real time, which you said it's not going to be available in 2025. Are you talking about L2 data or the raw data itself?
So we will provide kind of a standard offering into the market L2 data always. Now, of course, if you do have specific demands to accessing raw data, I think that's an individual conversation that we would be happy to have with you. But as standard offering, we would not have raw data supplied into the market in 2025. And about the real time or kind of latency related issues, that is now always talking about L2 data relating to our standard offering.
Okay, I think that's it. Wonderful. Well, Beata, Elsie, thank you for doing that. Thank you to everyone who participated. We'll make sure to share the recording with you. And till next time, thank you. Thanks a lot.
Been a pleasure to have so many with you. Thank you very much.